as you would expect from any debugger, we can jump forwards in code, we can add breakpoints, and of course we can navigate to those breakpoints at will. But what's interesting about CodeTracer is that we can do every of those steps in reverse. So we can jump backwards to a previous breakpoint, or navigate backwards to to a previous line of code. Here in the top right part of the screen, we see what we call a code trace. The code trace is essentially a list of every function call that is going to happen throughout the code's execution. And if we collapse the two functions here in the top level, we can see that this corresponds to the code that we see. We have in this simple test program 2 test cases. We call the iterate asteroids function 2 times, and this is what we see in the code trace. So we can use this code trace to navigate easily to each of those function calls. And now that we're in the iterate asteroids function, we can see the next feature of CodeTracer, which is its omniscient loop controls. So here we have a loop, and we can easily navigate through each step of the loop. And of course, this works in reverse as well. And not only that, but let me zoom in a bit. We see the values of each variable in line. So as I move the slider, we see all the values update according to what has happened in the program's execution. And if you pay close attention to the bottom right part of the screen, we see that actually there's something reacting to those jumps. And this is what we call the event log. The event log is a list of every of your program's interactions with the outside world. So everything that is non-deterministic, that somehow may return an error or have some unpredictable outcome, like, for example, network events, file events, errors, stream events, or whatever. Everything that is not deterministic is recorded, and a snapshot is taken of the program at that moment, so that we can reconstruct the history of what will or has happened in a precisely the same way each time. What else do we see on the screen? So here in the top part of the screen, we see the state panel. The state panel essentially gives us an overview of what the current line of code has access to in terms of local variables. So here we see a list of all the local variables that line 15 will have access to. But not only that, but because CodeTracer is omniscient, we can also see the history of each variable. So, for example, the damage variable was initially not assigned, then it got a 0 assigned to it, then it got a minus 20,000 assigned to it, and so on. Another cool thing that we can show today is the trace log, and this actually allows you to inject code into your recorded program as you're debugging. So for example, I can achieve the same thing as before with the variable history by just logging the damage variable. And now we see a list of every instance where of every time when the program passed through this line of code, what exactly the value was of this variable. But we can do more with this. We can also, for example, log the iterator. And this will allow us to better visualize what exactly is going on. Because now, as we see, here we have the iteration equals to 0. This means that we went through a second time through this function, and this helps you pinpoint issues more easily. Another cool feature that we have is the scratchpad, which allows you to set some variables aside to look at them at a later time. For example, this is very useful when you have some objects with a lot of properties and you just are interested in some small part of it and you want to compare two things, but you have to navigate to get those different things. So this is one of those features, and in the future, CodeTracer will have the ability to load a multitude of projects at once, and this feature will become even more useful when this happens. So this is cool and all, but how do we, how would we use this debugger in a normal debugging session, for example? And for this, I have prepared a very simple program. It's called Spaceship. And this is something very simplistic. You might include this, for example, in your video game, just as a small part of your game. Here in the example, we have a spaceship with a space shield, and it's passing through an asteroid field. And some collisions are inevitable, and we have to see if the spaceship will survive or not. And there's a catch: the shields get exponentially less efficient as the more drained the shields are. So at 50% shields, an asteroid would do 50 times more damage. Okay, with that aside, let's see what this example does. Here we have all the two arrays with the positive and negative test case. The damage, as you can see, the first time is just as we expected. At 100% shields, the damage should be 100 for the first asteroid. Great. But if we scroll down a bit, we see that in the final result, the test has failed. So we expected the ship to be destroyed in the negative test case, but it survived. And just from the logs, it's not immediately obvious why this is. So in those situations, it's very helpful to have something like a variable history. So let's navigate again to the function where the magic happens. And I could, for example, take a look at the all the different values here. So in the damage, I don't see anything suspicious. Let's take a look at the remaining shields, and nothing too suspicious here either. Maybe the origination? No? Okay. Now that we don't know how to continue, we can do something else. We can log several of the variables at once and see what this brings us as new information. So I'm going to log the damage again, the remaining shield, and the regeneration maybe. And now we can see, when we go through this, that actually there's a point in time where the remaining shield is minus 670. And this wasn't really obvious from the logs here, nor from the state panel, but we had a way to log it. And this didn't require me to go back into the project, to add a control log, to rebuild it again, to launch it again. It just happens inside of the debugging session. And now I see a problem and I have no idea how to fix it. But I know a colleague of mine who has the answer. I know he's very smart, he can fix anything in this world. So what do? I can restart CodeTracer, and the last recording of that we did of the program is the first one here in the recent traces. So we can upload this trace, copy the link from it, and I'm going to run a command to delete all the traces from my computer. So 1 second, just clear local traces. And now if I run CodeTracer again, we see that we don't have anything recorded yet, but I have the link to download the online trace. This, for example, happens on his computer, on my colleague's computer who knows everything, and he just pastes the link in, presses download, and voila, he has a copy of the bug reproduced without any further setup time and so on.